Welcome everyone. The question that is shown on the screen it is from the CBSE 2026 physics question paper. It is a 2 marks question. A battery of EMF 21 volt. Okay, so this is the we can say this is the battery and its EMF is 21 volt. An internal resistance 3 ohm is connected to the resistor. Okay, since internal resistance is there, I always prefer to place this internal resistance in series like this way, and this thing now serves as a battery, and obviously quite evident that I am not getting the 21 volt as a potential difference across the battery, something less than that of it, and that is depending on which resistors I am connecting as the external resistors, depending on the current flows in the circuit and depending on the potential drop will occur across this internal resistance, and depending on the terminal voltage of the battery will change. If I say this capital R is the external resistance of the circuit and I is the current which is flowing from the battery, passes through the capital R and then passes through the small r and just ends up its journey after completing the loop. So I can simply say I multiplied by capital R. Why? Because I current is flowing through R, plus I multiplied by small r because I current is flowing through this internal resistance. Either I am writing down minus E, because if I rotate the anti-clockwise sense, then the negative terminal of this EMF cell hits first. Okay, so minus E equal to 0. So from it, if I want to find it out what is the current, then obviously I have to take this I common from this I capital and I smaller, that is capital R plus smaller equal to E, we can say. So what is the value of the current? Value of the current is EMF of the cell divided by the external resistance plus this internal resistance. Okay. Okay, in the question it is given if the current in the circuit is 3 ampere, calculate the resistance of resistor. That means capital R, we need to find it out. Okay, so I am using this formula. So it is 3. The value of the E is 21. Capital R we need to find it out, and the small r is 3. So after from this we can write it down simply 3 capital R plus of 9 equal to 21. Please check it, simple calculation. So 3 capital R equal to 21 minus of 9. So 3 capital R equal to 12. So capital R equal to 12 divided by 3 equal to 4 ohm. So 4 ohm is the resistance of the resistor. What is the terminal voltage of the battery? That means we can say that is the capital V. Capital V is the terminal voltage of the battery. So the terminal voltage of the battery can be easily find it out by a simple common sense. Simply the common sense, and the common sense is C EMF of the cell minus of I into smaller. Try to understand that here. Capital E is a 21 volt. Okay, so from it the current is coming out. Okay, and IR is the potential drop across the internal resistance. So this much it is reduced, and I is 3, smaller we know it is 21 minus the value of the I in the question it is given 3. The value of the internal resistance in the question is given 3. Okay, so it is 21 minus 9 minus 9, that is equal to 12 volt. This thing can be done also in a different way. Since here only one resistor is connected, so what is the terminal voltage across this battery? Okay, the same voltage appeared across this external resistance capital R. If I calculate I into R, just see the alternative way. If I calculate I into capital R, what is the value of the I? I is 3. The value of the R is 4. So 12 volt is the potential drop across this capital R resistance. So what is the potential drop across the external resistor? It is same and equal to that of the terminal voltage of the battery. Okay. So this way also we can calculate. So the internal resistance of the resistor, external resistor is 4 ohm and the terminal voltage is 12 volt. Thank you all.